Welcome back, everybody. We are still in section 9.1 talking about our six trig functions. And for this part, we're going to start with, we didn't get a triangle. Instead, we got one of our six trig functions. And so we have to give the other five based on the information we know or whatever they ask us for, which in this case is tangent. So I'm going to go ahead and draw a right triangle. I'm going to put in a theta, and I'm going to label opposite, adjacent, hypotenuse. Now, cosecant is the inverse of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So that means that we know our hypotenuse is 8 and our opposite is length 3. Tangent, TOA, OA, is looking for the opposite over the adjacent. Okay, well, we know that the opposite is 3, but we don't know the adjacent. So we're going back to our good friend Pythagorean theorem, and we are looking for adjacent. So a squared plus 3 squared is equal to 8 squared. 3 squared is 9. 8 squared is 64. So we'll subtract the 9. We have a squared is 55. And take the square root. Square root of 55 is not a perfect square. I break that down into 5 times 11. Those are both prime. I can't pull anything out. So the square root of 55 is as good as that one gets. Now I can go ahead and find the tangent. So tangent of theta, opposite over adjacent. Example 6. We know cosine, find cotangent. Cosine, ca, a, h. So if I draw my triangle and I label theta, remember your right triangle doesn't always have to look like this. You can have your theta in either corner and the triangle can be facing the other direction. See, I've got side opposite, side adjacent, and then the hypotenuse. So labeling what we know that adjacent is 2 and hypotenuse is 5. Cotangent is the inverse of tangent. Tangent, TOA, OA, means that cotangent is AO. Well, we know A, but we do not know the opposite. So, Pythagorean theorem, we have 2 squared plus b squared is equal to 5 squared. And if you made your equation a squared plus 2 squared equals 5 squared, remember that's okay. And 25. I'm going to subtract the 4. So b squared is 21. I'm going to take the square root. Again, 21 is not a perfect square. I can break that down into 7 times 3, but there's nothing there that I can simplify out. So square root of 21 is as good as that side opposite is going to get. So cotangent of theta, A over O. This answer is good. Remember, we should be rationalizing our denominators, so I'm going to review that here one more time. Don't like the square root of 21 on the bottom, so we multiply the top and the bottom by the square root of 21. On the top, cannot multiply 2 and 21, so they just sit next to each other. And then on the bottom, the square root of 21 times the square root of 21 simplifies to 21. There's no reducing I can do for that, so that's the final part of our answer. Thanks, everyone. See you next time.